So in this video today for Unit 3, Section 5, we're going to go over triangle congruence, and we're going to talk about 3 more ways that we can, shortcuts that we can use to prove that triangles are congruent. So I want you guys to remember, if you're my student, that you should be working on the USA Test Prep midterm practice test every day, and that it's due on Monday. And again, don't click the submit button at the bottom until you've completed it. Until you've completed it, you should be clicking on the thing underneath it that says save. That way you don't have to keep going back and restarting it. Also, there will be a quiz on Friday on Unit 3, Sections 4 and 5. So that's what we did yesterday and what we did today. So these are some problems that we did in class today, just again to reiterate what you guys did on the quiz, and some of y'all didn't do so well. So let me go over these. So we've got this 15-degree angle and angle B up here. It's asking us to find B. Those two angles, when we add them together, they equal, so that would be 15 plus the measure of angle B. That equals the exterior angle out here. That's this angle right here. So those equal 70. So we would obviously subtract 15 from both sides, so the measure of angle B is equal to 55 degrees. And this was the exterior angles theorem. And this was what was on the quiz, exterior angle theorem. And so we're going back over this because a lot of my students missed this. Number 2 says find the measure of angle A. Here again, this would be the triangle sum theorem. That's what we would use, the triangle sum theorem. And when we do this, I told my students you could do 90 plus 40 and subtract that from 180, or you can just subtract the 40 from the 90 because we have already used 90 degrees. So that would be 50 degrees. And again, this is the triangle sum theorem. The third problem that we went over here was finding x when we have that already that triangle ABC is congruent with triangle DEF. Once again, you should notice here that AB maps to DE. And if that's the case, and it is, then we can put tick marks on these sides. And that means that corresponding parts of these congruent triangles are congruent. So our reason for solving this, or the way we solve this, is CPCTC, 3 C's PT. So we can now set 2x minus 2 equal to 6. So 2x is equal to 8. So x is equal to 4. So again, these are just reviews of some of the problems that we have done prior to this section. Next it says, what are the sides of AC and BC called, and what is side AB called? So first of all, you should recognize that this is a right triangle. And if this is a right triangle, then AC and BC are both legs. And the side opposite the right angle is the hypotenuse. And that would be AB. And you guys should have learned this in middle school, but we are going to revisit it. Then it says name the side in between angle A and angle C. Angle A is up here and angle C is down here. So the side between angle A and C is side AC. Number 3 down here says, given that DEF and given DEF at triangle DEF and triangle GHI, if D is congruent to G and E is congruent to H, what is true of angle F and I? This is another question that was on the quiz, and this is the third angles theorem. Remember, if 2 angles of one triangle are congruent to 2 angles in another triangle, then the third angles have to be congruent. And let me say again, the triangle sum theorem is used in one triangle. The third angles theorem is used when you have 2 triangles. Our objectives today are to apply angle side angle side HL, which is hypotenuse leg, to construct triangles and to solve problems, and to prove that triangles are congruent by using those. Our vocab today is included side, and we're going to talk about that right now. An included side is the common side of 2 consecutive angles in a polygon. The following postulate uses the idea of an included side. So notice that we have angle P on the left and we have angle Q on the right, and the side that is between those 2 angles is what we call the included side, and that is side PQ. So now we're going to look at the theorem where we're going to use this. So we are going to use, now we're going to use what's called angle side angle. So notice here we have angle A is congruent to angle D, and then we have this side AC with one tick, and this side DF with one tick, and then we have angle C being congruent to angle F. So if we move from left to right here, or right to left, doesn't matter which way we moved, we have an angle, and then we have a side, and then we have an angle. So this is what we call angle side angle, when we have two angles in its included side that are congruent. So it says here to determine if you can use angle side angle to prove the triangles are congruent and explain. So the first thing we want to do is go ahead and mark what we can mark on this drawing. And as we have been doing, we're going to be able to mark the shared side, XB, and then we can also mark this right angle because that's a linear pair right there, forms a straight line, and so if 90 is used, then 180 minus 90 is 90. So now what we're going to talk about is we're going to move through this triangle. So we're going to talk about this angle being congruent with that angle. So that's angle UXV. U has nothing on it, X has one arc on it, and V was a right angle. So over here when we talk about this angle, we're going to move the same way. So we moved from nothing to 1 to right. So over here we're going to go from nothing to 1 to right when we talk about the angle. The next thing we're going to talk about is this side, XV. And notice when we move across this triangle, we move across XV the same way, whether we're doing UXV or WXV. We move down with both of them. So we're going to say XV is congruent to XV by the reflexive property, because we have the same thing on both sides of the equals or the congruent sign. Then we're going to talk about our third angle down here, and that's this one down here. So we're going to talk about UVX, again, nothing, right, 1, and WVX, nothing, right angle 1. So remember, when we're doing this, we got to make sure that we move in the same directions around the triangles. Now that we can see that we have an angle here, we have a side here, and we have an angle, we can say that these two triangles are congruent by angle side angle. So again, we're going to look here, how are we going to do this? Normally I do this in alphabetical order. So I would say UXV or UVX, doesn't really matter as long as we move in the same direction again. So I said UXV, so UXV was nothing, 1, right. So I got to go from nothing to 1 to right here. And again, they're congruent by angle side angle. So our next one says determine if we can use angle side angle to prove the triangles are congruent. Once again, we have a shared side. So here again, we're going to talk through this one. And we're going to talk about our angles. So we have GFH. So GFH is this one arc angle up here. And so we need this one arc angle down here. And again, we move from nothing to 1 to 2. So here we're going to go from nothing to 1 to 2. That's how we got the angle. Then we're going to talk about our side. Now I want you to notice something when we talk about this side. Whether we say FH or HF, I want you to notice when we talk about this triangle on the left, we go from 1 to 2 and it's going up. And when we talk about the triangle on the right, we go from 1 to 2 and it's going down. We're not moving the same direction across that side. So in this case, we would be using the symmetric property because we're not moving the same direction across that shared side. Then we've got GHF is congruent with IFH. So that's our other angle. Again, GF, sorry, I said it twice, didn't I? So yes, here again, we're going to say GHF. So we're going from nothing to 2 to 1. So out here, we're going to go from nothing to 2 to 1. So it's going to be IFH. Once again, when we talk about our congruent statements, we have to move around the triangles the same way. So if I say FGH, that would be FGH would be 1, nothing, 2. So down here we have to go 1, nothing, 2. We're talking about the triangles. And they are again congruent by angle side angle because we had a pair of angles here, we had a pair of sides here, and we had a pair of angles here. So the next one says, determine if you can use angle side angle to prove that triangle NKL is congruent with LMN, and explain. So the first thing I know I can mark is that shared side. Then I want to show you a couple things here. So on this one, we have this line is parallel with this line down here. So we have the line KL is parallel with NM. And hopefully you can see this transversal here. Can you guys see that transversal? Well, if so, then you should be able to see that this angle would be congruent with this angle because they're alternate interior angles to each other. So here's the big hint, guys. Every time we prove triangle congruence, we have to have at least 3 things. And in this drawing, when we talk about the triangle up here on the top, so if we talk about this triangle up here, I right now only have 2 things. I have that arc, which indicates that I have one angle, and I have the tick mark, which means I have one side. That's not enough information to prove that these 2 triangles are congruent because I only have 2 pieces of information. So once again, we can say that the angles are congruent by alternate interior angles theorem. We can say that that this transversal right here is congruent by the symmetric property, but we don't have any other congruence relationship, so we cannot use angle side angle. Now I want to look at the same problem, only I want to add a couple things to it. So this time I'm going to say that I actually have 2 pairs of opposite sides that are parallel. Now we just said that that was true because it's a shared side. Sorry about that. And we said that this arc was congruent with this arc, right? Or that angle, sorry. That angle was congruent with that angle. Now because we have a pair of parallel sides, a different pair of parallel sides, this pair right here, and now we're talking about this transversal, y'all see that? So now we can actually talk about this angle here being congruent with that angle there. Same reason as the other one, but we had to have both pairs of opposite sides that were congruent. So this time we could say that those triangles are congruent. And again, let's look at the triangle and we'll walk all the way around it. So here's our triangle right here. And this time notice we have angle, side, angle. So because of that, we could say that these 2 triangles are congruent. And the only reason we can do it on this one is because we had 2 pairs of opposite sides that were parallel. So we would have had to have that KN was parallel to LM to be able to say that the 2 triangles were congruent. All right. So let's look at this one. I want you guys to go ahead and do this one and then come back to me. So we're only going to use the given information in this drawing. Everybody in the room hopefully knows that we could have put vertical angles here and here, but we're going to use the given information because sometimes in problems on the EOC and the DA, it's going to tell you that. Only use the information given. So here we should be able to say that P is congruent with T. And we have the side PS, which is congruent with TR. And then we have S, angle S is congruent with angle R. So here again, what do we have? We have a pair of angles, a pair of sides, and a pair of angles. So we can prove that these 2 triangles are congruent by angle side angle. Once again, we're going to talk through this triangle. So we could say PQS, 1 arc, no arcs, 2 arcs. So again, we would go 1 arc, no arcs, 2 arcs to write our statement. And we would say again, they are congruent by angle side angle. So this is the next one here. So this one has to do with 2 angles and a side. So we have 2 angles right next to each other and then a side at the end. So here again, we have angle G congruent with angle K, we have angle J congruent with angle M, and then we have a side. So I want to tell y'all right now that this is called angle side. We will never have one that is got 2 sides next to each other with an angle, okay? So we're never going to see SSA or ASS. So what I tell my students is there's no but, obviously that word, or but backwards. That's the way to remember it. There's never going to be two S's next to each other unless you have side, side, side. That's the only time you're going to have SSA or ASS, okay? I should say it this way. That's not true. The only time you're going to have two S's together is when you have side, side, side. That's it. That's the only time. Otherwise, you're not going to have two S's next to each other. So on this one, y'all should like this one because there's no letters. So the only thing that we have to put a mark on this time is a shared side. And then we should be able to see that this is angle, side, angle. And I want to bring to your attention once again that I'm only moving around one triangle, not moving around both. That would be confusing because what we're determining is one triangle congruent with the other one. So we're looking at the markings in one triangle to determine if the two triangles are congruent. This one here. So here again, we have angle G is congruent to angle K. We have that J is congruent to M because it has two arcs on it. And then we have this one tick side. HJ is congruent to LM. So once again, as we move around this triangle, we could say G, HJ, I'm going to move alphabetically, is congruent with KLM. I went from 1 to nothing to 2, so I'm going to go from 1 to nothing to 2. And these are congruent again by angle, angle, side. Because this was an angle, this was an angle, and this was a side. So here's our next one. It says use angle, angle, side to prove. So given that BC is congruent to DC, and it gives us that in the drawing. Now here again, I hope you notice that we have these parallel lines here. Hopefully all of y'all noticed that. So if we have these parallel lines, and we have two sets of transversals this time, notice. So we have a transversal there, which would net me a congruent angle there and a congruent angle there. And then we have another transversal right there. So we have a pair of angles that are congruent there and a pair of angles that are congruent here as well. So I don't want y'all to mark the vertical angles in this one, okay? However, we're going to talk about that, what would happen if we did. So right now, how could we say that these two triangles are congruent? Again, hopefully you can see that we have an angle, and then a side. Same thing over here, right? Angle, angle, side. So we don't count things that don't have tick marks or arcs. So if they're not right next to each other, then we don't count that. I had that question earlier today. So when we talk about this one, AB and ED are parallel and AE is transversal. So that's why we said that angle A was congruent with angle E. Again, BD is a transversal to the parallel lines AB and ED. So we said that B and D were also congruent by the alternate interior angles theorem. Then we said that BC was congruent to DC. That was actually given to us up here. So again, what do we have here? We have currently an angle, and a side, right? So once again, we're going to move around our triangles. Triangle ABC, and I usually like to go alphabetical order here, ABC. So this went 2, 1, nothing. So what are we going to do over here? 2, 1, nothing. So look at your arcs in the triangles to determine how to make the statement. So this time again, they're congruent by angle, angle, side. Now I want to talk to you about this. Because vertical angles are congruent, we could also say that these angles right here were congruent, right? So if we said that, then we actually have several that we could do here. We could say also that it is angle, side, angle, right? And angle, angle, side. Either one of those would work for this problem. Okay? All right, so the next one has to do with the hypotenuse and the leg. And we talked about hypotenuse earlier. Remember, first of all, we only have a hypotenuse in a right triangle. So our hypotenuse is here, opposite the right angle, and our leg could be either one of those other sides, okay? So HL can only be used with a right triangle, okay? So here in this drawing, first thing we're going to say is ABC and CD, ABC and DCB are right triangles, right? Can you all see that? Both of these are right triangles. They have right angles in them. So that's the first thing that we can say. And then we should be able to see that AC is a hypotenuse. It's opposite the right angle. And BD or DB is opposite this right angle, right? So then we have a leg, we have another shared side here that is congruent. So we then can say that the two triangles ABC and DCB are congruent by HL, which is hypotenuse leg. The next one. This one has, again, two right angles. And remember again, this is our hypotenuse opposite the right angle. So on this one, we do have that there are two right triangles. So we have that XZ is congruent to AZ, and then we have that XY is congruent to AB. So we have proven hypotenuse leg. Our three parts with respect to a right triangle are the fact that it's a right triangle, a hypotenuse, and a leg. Those are still three parts. We always have to have three parts for us to prove congruence. Minimum of three parts. Okay, so let's talk about this one. It says, determine if you can use HL theorem to prove the triangle's congruence. If not, tell what else you need to know. So on this one, we would have another right angle there because those form a linear pair. And we have a shared side. So do we have enough information? The answer is yes, we do. So it is given that the hypotenuse are congruent, and therefore the triangles are congruent by hypotenuse leg. Now this one right here, let's talk about this one. So again, we have two right triangles out there on the outside, and we have one leg. What do we not have on here? So right now, we have that the legs are congruent, right? But we do not have anything that tells us that the hypotenuses are congruent. Thus, we cannot prove that these two triangles are congruent by hypotenuse leg. All right, so now, at the bottom of y'all's page of notes, we have three things to prove triangles, right? We have to have three things every time. If we don't have three things, we can't prove the triangles are congruent. So the 5 ways that we prove that triangles are congruent are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So what can we mark on drawing? So we're going to talk about that, and then we're going to go over what was on the bottom of the page. We can mark vertical angles. We can mark a second right angle in a linear pair of angles. We can mark a shared side, and we can mark alternate interior angles when there are parallel sides. So let's look at these drawings. So with this first one up here, we can mark the vertical angles, right? So when we mark the vertical angles, hopefully you can see here side, angle, side. The next one. On this next one, we can't mark anything on the next one because there's no way to mark anything. There's no reason to mark anything. And remember, you can't mark something if you don't have a reason for it. So here we have a side, and then an angle up there. So let's talk about in order. Angle, side, side. Do y'all remember me telling you that we can't have two S's next to each other unless we have side, side, side? So these are not congruent because there is no such thing as angle, side, side, right? There's no such thing as angle, side, side, okay? No such thing, okay? So then our next one, again, we can mark our shared side, and we have over here an angle, a side, and an angle. So this one's angle, side, angle. All right, let's look at this next one down here. Oh, we got a right triangle, right? We've got a right angle and a right angle. Well, does that automatically mean that it's HL? No, it does not. We do have the hypotenuse in this one, but we do not have a leg, okay? So we have an angle, and a side, right? And an angle, and a side. So this one's going to be angle, angle, side. Okay, now let's look at this next one. This time, again, we have a shared side here. Hopefully y'all can see that. Well, looks to me like we have 3 sides on this one. 1 tick, 2 ticks, 3 ticks. So this is side, side, side. Now let's look at this last one over here on the right. So we have 2 right triangles, right? And we have a shared side. That shared side, guess what it is? It's the hypotenuse. So that makes BC and DA our leg. So these are congruent by HL.